Okay. I believe we are live. Yes, and we are live. So welcome guys to World Quant University Office Hours number 2, Unit 1. It's not quite the start of office hours, but I thought I'd join a few minutes early just to make sure everything is up and running. My name is Don. I'll probably introduce myself multiple times as people come into office hours. But yeah, let's see who is out there. Let's see who is joining us for office hours. I see Anik is here. Hello, Anik. Ankit. Sorry, I mispronounced your name. Or at least Ankit. Hopefully that's closer to the pronunciation. Ankit. I'll try to remember that. Hello, Ankit. Looks like you are joining from India. So hello. Welcome to the course. All right, see more people streaming in. I see Bishnu. Hello, Bishnu, coming from India. I see Salau coming from Nigeria. Hello, Salau. I see Rahika. Hello, coming from India. Alvin. Hello, Alvin. Good to meet you. I see Jeff coming from Vancouver, British Columbia. Never been, but I should probably go sometime, hopefully in the near future, after all this is over. Manish, hello Manish. Abdul Karim, hello Abdul Karim from Turkey. Hope everything is going fine. I see Christian coming from Bolivia. Hello Christian. Teherina. Yeah, Christian Teherina. And I see Omadara from Nigeria. Hello Omadara. Greetings guys. Welcome to World Quant Office Hours Unit 1. The second one of the course. Hopefully everyone is doing fine and dandy wherever they're located. Thank you for sharing where people are signing in. It's kind of great to see where people are coming from all over the world. Dedunualo. Hello, Dedunualo. Hello, Tom. Hello, everyone. Settle yourselves in for office hours. Okay. If you didn't catch, my name is Don. I'm one of the instructors for World Quant. In fact, I'll be the primary instructor for office hours. However, this week I cannot do 2 of the office hours, so I had a colleague, Michael, fill in. So yesterday you might have met Michael. He's filling in the office hours for yesterday and Wednesday. But after that, I will be hosting the office hours, for better or for worse. So hopefully we'll get to know each other a little better. I see Madhiha. Hello, Madhiha, coming from Toronto. Hello. All right, and I see that Nuala, and they deferred from a previous session, and now they're back with us. So hopefully you're able to complete the program this time around. I hope so too. We're here to help each other out and learn and make progress and complete those mini projects, complete those assignments. Okay, let's see. Amrita is here from India. Hello, Amrita. And what I like to do for office hours, can you take our class always? Can you take our class always? I will be doing the office hours for Unit 1. I won't be able to do it for tomorrow, but after tomorrow, I will be able to do all of them. It's only only 2 of this week I won't be able to do the office hours given my schedule, but I will be doing them from next week and for week on. I will be always doing the office hours for Unit 1. And I see that Sai is here. Hello, Sai. Bukala is here from Nigeria. Akona Felix from Nigeria. Hello, guys. Looks like a big Nigerian presence in office hours. Hopefully everyone is doing fine. And what I like to do for office hours is I like to create an agenda. And what I usually do in the beginning of office hours, I say, before, what I do is I greet people. I like to, I like to greet you guys, seeing where you guys are coming from. And what I like to do is start off with create an agenda of what we want to do for office hours. In this agenda, maybe some of the topics that are, and this is where I say, hey guys, let me know for your, what you want me to talk about for office hours. Some of those topics I may not get to. Maybe they're for later weeks, or maybe I have to think about a little more so I can come to office hours a little bit of a prepared plan. Not that I can't teach some of the stuff you bring up, but it sometimes is nice if I sit back and come up with kind of a detailed plan for better explaining the concept. And what I do is I record this agenda on a pad of paper, and I see where it would fit in our curriculum. So I may not get to the topics that you might bring up for the agenda for office hours, but I like to record it. I like to make sure that I don't forget about it, and we have a time reserved to discuss that, so I tend to do that. The other thing I like to do for office hours is work through the mini projects. Work through them, ask you guys what your thoughts, see different approaches, compare and contrast, have those conversations, grow as we go through those mini projects. So that's what I like to do for office hours. And now let me see who else has joined us. I see Bismarck coming from Ghana. I see Alicia Bauer coming from Germany, Matisia from South Africa, and Fabi coming from Germany. And Siddhartha is asking, is this Unit 1, Unit 2? This is Unit 1. And I see Vidi. Hello, Vidi. I see Nale coming, saying hello from Mexico. And Naye, I'm kind of curious to see what part of Mexico you are coming from. And the reason I ask is, I have family in Mexico, so maybe your neighbors with my family. So if you're comfortable, let me know, where part of Mexico you're from. I have family in Monterrey, Reynosa, and Tula, Tamaulipas. I see Ebisi coming from Ethiopia. Hello, Ebisi. And what I'll do is I'll introduce myself a little bit. I'll give you a little bit of my background, so you kind of know where I'm coming from. Kind of know what's my background, how I came into data science, that kind of thing. So let me introduce myself. My name is Don. I'm one of the instructors here at the Data Incubator. One of the things I do is I do WorldQuant. I help out with WorldQuant specifically for the office hours. If you go on to Unit 2 and you see those videos we have for Unit 2, I am the voice behind those videos. So for better or for worse, you'll hear my voice if you go on to Unit 2. I see Anaya coming from Campeche, but now living in Mexico City. All right, cool. Well, hope you enjoy Mexico City. I have a friend who really enjoys it there. Fernando is his name. So my background, I have an undergraduate degree in chemical engineering. That is my background. That is my undergraduate degree. And after I completed my undergraduate degree, I went on to a PhD program also in chemical engineering. I did chemical engineering both for undergrad and graduate school, and that sometimes reflects how I teach things. I kind of view things as steps and units of processes, and I kind of view data science and machine learning as a workflow that you construct. Just like in chemical engineering, you have a raw set of ingredients and you go through different steps and processes for a final form. And that final form is a cleaned up process data or a trained ML algorithm to deploy and make predictions. So because of that, I tend to view things as chemical engineering. I see there might be a couple chemical engineers out there. That is my background. And for my graduate school, what I focused on was simulations, numerical simulations, both numerical simulations and solving differential equations for the thermohydraulic processing, of geothermal energy systems. And so, I'm talking a little about my background, Bishnu. Hopefully I get to answer, why I became a data scientist and so forth. If you take, this is the Earth, this here, and one of the things as you attend my office hours, I do a lot of drawings. I do a lot of whiteboards. So we're going to see a lot of me sketching things on this whiteboard. So here's our house, our building. And if you dig deep enough into the Earth, you will find a hot pocket of rock. So you go deeper into the Earth, you find hotter and hotter rock. So one source of this renewable energy is to drill a hole and identify some sort of fracture network. And here, hopefully the temperature is maybe greater than, let's say, 250 degrees Celsius, hopefully. And hopefully we don't have to deep so far. Hopefully we don't have to drill a hole too deep to reach that resource, because drilling costs are expensive. It's very expensive to drill a well. Very expensive. So the shallower we go, the better, but we want to go deeper. So there's a trade-off here. We want to go deeper because we get hotter resources, the better, but capital cost constrains how deep we can go. So one of the things that I did for my PhD was modeling what would happen if we inject fluid through a fracture network and we pump it up back to the surface. Flow and injection water, cold water flows through a fracture network. It heats up. Imagine flowing water through a hot resource, some hot rock, and pump it back up to the surface. And this here is a renewable energy source, because if you deplete it, if you flow water long enough, you'll cool down the pocket of rock. But it's surrounded by hot rock, and we still have heat flow from the center of the earth. So one of the things I was doing is modeling this thermohydraulic process, understanding how long these reservoirs will last, but also understanding how long we have to let them recover so we can reuse them again. So I was writing basically programs solving finite element the finite element equations, the finite element method to model this process here. Some of the things I was doing is running simulations of these reservoirs under different characteristics and different geological constraints and inputs, and seeing how that affects production temperature, and doing data analysis on those simulation of data. So one way I kind of view myself towards the end of my PhD was I was basically I was doing some data science stuff, but it just so happens to be in the field of chemical engineering. I see Japhet coming from Zimbabwe. Hello, Japhet. Thank you for joining us today. So that's what I did for my PhD, thermohydraulic modeling of geothermal energy systems. And then afterwards, I worked for a renewable energy startup company, where one of the things we were doing is we had a geothermal energy technology. And the problem with renewable energy is that it's really hard for it to compete against traditional energy sources. We've optimized, generating energy from natural gas, petroleum resources, and coal. Right? They're just old, very established technologies. So it's very hard for renewable energy to really compete against those. So we had a geothermal energy technology that was a bit different. I won't be able to show you all how it works, because that was sort of one of our secrets. But it was sort of better than the traditional approaches. And I see someone coming from Oman. Hello, Amrita. Hello, Amrita. And I should probably mute my Slack because my things pop up. So give me a sec. Do not disturb. 1 hour. So I got my Slack notifications paused. So sorry about that. Okay. And we want to figure out where's the best place to deploy this technology across the U.S. And this is my crude drawing of the U.S., but also across the entire world. And one of the things we need to know to figure out where's the best place to implement this technology are really two things: the geological conditions, but also what is the levelized cost of electricity for that given market. Because we're really looking for a place where our technology will be easy to implement, so levelized cost of electricity will be small, but hopefully cheap enough that we can compete against the energy sources for that given location. So one of the things I had to do was work with heat map data. Heat flow maps. Let me just show you. I can Google it to kind of show you kind of things that I was working with. Things like this that show you the heat, how much heat is coming from the surface of the earth. We can use this as input data to get a good guess of the geologic conditions, of how successful will implementing that project be. And these heat maps exist not only for the U.S., but for other all around the world. There's even one about Mexico. And you can see certain parts of Mexico where it's probably easier to implement this type of technology. So can we take this heat map data? Can we take data about abandoned wells to estimate sort of bottom hole temperatures, get connectivity measurements, and look for places where we can implement technology in abandoned wells because they've already drilled the well, they've abandoned it, the capital cost is already paid for. It'll be easier to implement our technology there. And can we look for abandoned wells that are kind of clustered together so we can have a rotating system? Use this well, we deplete this resource, no problem. We know how long it takes to regenerate. Move on to another well. Move on to another well. Move on to another well. So that when we go back to the first one, it would have recovered. We call this strategy heat farming. Because you farm from one area and you let that land go fallow. You let it fallow. You let it recover its nutrients. How you would do in farming. In this case, we're allowing that resources to heat back up. And we can kind of go back to the original one after we let enough time for it to recover. And I was working in Python. I was also using Python to run finite element simulations of our technology. I was using Python to analyze this heat flow data. I was using Python to analyze a data set of abandoned wells to figure out where should we best implement this technology. So essentially, I was doing a lot of things that were data science-y, but I didn't have a label of a data scientist. And but that was fine. And one of the things I like to do is I like to teach. I like to convey my understanding to people. I like it when people get excited about what they're learning and feeling comfortable enough that they want to apply what they're learning on some sort of project or whatever they're working on or their field of interest. Probably, if we've seen this chat here, we're coming from all over the world. And we all have different backgrounds. You know, I see some chemical engineers. I see some geologists, right? We can all make use of data science. So I like hearing what things people get excited about, what we can use data science for. And then I started working for TDI, the data incubator, as a data science instructor. And that's what brings me here today. So that's a little bit of background about myself. I was born and raised in South Texas. And here's Texas right here, right in the border. A lot of my family comes from Mexico. Yeah, that's a little bit about me. This is a point, if I were doing an in-person lecture, I'd say, let's go around the table and tell us what everyone, a little bit about themselves. It's a little harder to do, but if you want to put a little bit about yourself in the chat, by all means, go for it. All right, so I'm going to take a look at the chat. Sometimes I'm teaching, so I kind of have it on the side. So I'm going to go ahead and look at the chat, see what's going on. And if people have any follow-up questions about me and my background, let me know. And also let's forming that agenda. I think I understand this first week, there's a lot of administrative questions about how does this work? How does that work? This, and that. Put those there. Let's get those answered. So I'm going to go look at the chat, see what's going on in the chat. I see we have Augustine from Nigeria. They are geology bachelors. Love the geological references. Yeah, we're working with granite is a primary source we're looking for. Granite. It's the type of rock most of this is implemented in. Got to know the thermal conductivity of the rock. Get those, estimate those heat flows. Figure out the temperature gradients. Okay. All right. I see Bismarck for your passion for teaching. Thank you. Can you please provide some motivation, like how to cop up with chemical engineering along with machine learning? Like it feels a lot difficult for me to make my progress in both fields. How to cope with chemical engineering along with machine learning. And yeah, if you're juggling both these two fields, it can be a bit difficult. And they kind of require different things, I think. But I would recommend just trying to find the analog between the two, the similarities. And in chemical engineering, you basically you would work with some raw ingredient, is sort of the classic chemical engineering case, some sort of raw ingredient. And it goes through various steps, different processing steps. I like to view these as different, in data science, it's going through some data and going through some cleaning process and some transformation and some manipulation. It's gonna be difficult to juggle both fields, but hang in there. And if I come up with anything specific about chemical engineering, I'll mention that. But hang in there. I think it's great I think it's really great when people come from a field that isn't data science, but comes from a specific field, because then they have the expertise of that field. And then we could think of data science as a tool. And you learn this tool, and then you can say, hey, where can I apply it in my field? Where can I use it in my field? Learn that tool, where can I best apply it? Okay. One of the things you also notice is I tend to drink a lot of water, so I might take some pause to drink some water. I do a lot of teaching, so my my voice loses out. Data science is a growing yes, data science is a growing field because people are realizing that data science can be applied for a large range of fields. Whether it's chemical engineering, and chemical engineering itself is a broad field. Geology, you can use data science in medicine, in finance, in security. People are realizing they need people with data science skills, but they also need people with that expertise. Maybe your background is geology. Maybe they need someone to apply machine learning or apply some data analysis on a data set they collected of perhaps a rock cores. All right, and yeah, I see automotive. I see Tom saying they spent 10 years in the coal industry, and then in Oregon, I guess, in finance and the automotive industry, and in the food industry. Yeah, so you're probably seeing all those fields, they require data science. Yeah, so I'm glad you're in this module. This is the first step, and now I see that he is retired, but keep on learning. Yeah, life learner. That's really it's all about making sure you've always learned. I'm always trying to learn stuff, and I'll be honest. Sometimes I'm teaching, so you know what? I'm not really sure about that, but no problem. We can learn. We can go ahead and look up documentation, learn about it, get more proficient, learn new cool things, apply them. Someone wants to know if there's some application that eases accessibility of lectures. And Hamza, is there a certain aspect of accessibility you're looking for? Maybe we do provide it, maybe we don't. Maybe we want to consider it for future implementations of our course. So let me know what aspect of accessibility you're looking for, if you're okay with sharing it, so I can better answer that question. And with that said, we can also start building up our agenda. Administrative questions, admin questions. That's what that means right there. Yeah, communications and advertising, right? That's another field, right? Figure out, maybe build profiles of people to figure out how to best target ads. How to figure out how to better target ads to people so you have a higher connection rate, higher click-through rate. Yeah, thank you, Bismarck, for showing, letting us know your background and what you're looking to apply data science. All right, let's open up the floor for agenda and questions people might pose, and I will add that to the agenda or answer them as time goes on. Areas in chemical engineering where the application of Python is most relevant. Yeah, and a little bit out of the game of chemical engineering. However, I know there's a lot of Python packages that people have written to analyze, let's say, molecular simulations of how molecules interact with each other, right? Molecular simulation. And there's probably a lot of Python packages for that. And let's see, I can go ahead and one of the softwares I was using in Python, it was called Phoenix. And Phoenix project. And basically what it is, it's a Python package. It's a wrapper, or it's for finite element differentiation, finite element method, solving differential equations in a finite element method. And it's basically a Python wrapper around C++. So with this here, you can do anything, any kind of numerical simulations, whether it's in the field of aerodynamics, mechanical engineering, aerospace, or chemical engineering. And this is all used you write your Python script. All right, Augustine says, how would you advise us to study within the week? And what I would do is, we post the videos at the beginning of the week. So around Sunday, the videos will be up there. What I usually recommend people is start viewing the videos and have the video and also have your Jupyter notebook and go them side by side. You might have to pause the video. You can always rewind, but go through the video, go through the notebook side by side. What I also recommend people to do is experiment. In other words, if I go here, I'm going to go to my pod. It looks like it shut down, so I'm going to go and start it back up. Okay, so I go here into data course. Let's say we are Python data wrangling and we're looking at The first notebook, so PY intro. And experiment. Maybe we do something, you're like, maybe let me try this instead. Open up a new cell. Play around. You can think of this as your playground. Modify things. Change things around. See what happens. So make sure you interact. Not only are you, I would prevent the passive where you just watch the videos. Do the active. Go through the notebooks. Run the cells yourselves. Manipulate cells. Change things around. If you are worried to do this because you don't want to modify things how they were originally, no problem. There is a way. There is a recovery. And I can post this in the chat here. But here is a set of instructions you would follow to regenerate those notebooks. So you can have ones that you modify and change around, but you can also generate ones that were like they were when the course started. And as you go through the course, if there's anything tricky, write it down. Make a note of it. Make a note of it. You can bring it up in office hours or take some time later to revisit that topic. So that's usually what I recommend people to do. Let's go on to VD, what we'll be doing in office hours throughout the course. So office hours, the way I structure it is about half of it is answering questions that you bring up, constructing this agenda. The other thing, part of the office hours is working through the mini projects. And if you want to work through the mini projects kind of on your own, that's fine. You can go ahead and maybe watch the video later. We do have a playlist of the video. And you may want to say, okay, well, I kind of want to try it on my own before I work on it. No problem. You can just go ahead and maybe set the volume low and kind of watch it later. Watch it later when you get to the mini project. But we will go through the mini projects. We'll kind of work on them. Let's see. Yeah, and so bring up your agenda because there might be things where I say, okay, I'm going to talk about that maybe next day, or I'm going to reserve that for later. I'll have that agenda. And one of the things that I will do, that I want to do, and I did this for the last group, was for the previous cohort, at the end, towards the last 2 weeks of office hours, we had done all the mini projects, and what we did was we worked on a web application. We learned some additional techniques that are not part of the curriculum, and we worked on a web application. Very simple web application, but the whole point is for you to be inspired by this project. You see the scaffolding, you see the template that we used, and you can take it and make it your own. Do something completely different, do some modifications, do some tweaks. We go through the steps of this project all the way to deploying this web application, all in Python. And I want to do that again for this cohort, for this group. And that's what I want to do towards maybe the last 2 weeks of this course as we go through all the mini projects and we work on them and we get very secure of what's being asked and get those solved. Work on this project. It might be something different. It might be something similar. I have to think about it, sort of constraint on my schedule and my other things that I have to do. But in fact, if you want to try this out, I'll put this in the link there. It's an application that takes your IP address and it figures out where you're located and it displays a little weather information. Okay, let me see. Surichi is saying, student computer science wanted to know what is the best way to start with data science. And I think the best way to start with data science is maybe a bit impartial, or partial, whatever the correct word is, with this module. I think it's go through this module, and as you gain comfortable with the techniques of data science, find a data set. Find a data set and start playing around with it. Start answering questions. Maybe you can pose a question like, I want to do X, Y, and Z. What are the data sets I have available? What are the data I can look for? And start seeing if you can answer those questions using that data. So I would say go through this course, start looking for data. I can find resources for data. Kaggle has a lot of data sets, open data sets, and start downloading them and start playing around with them. Start answering questions based upon that data. Tom is asking how many mini projects per week is a good rate, and there are 5 mini projects in this course. 5 mini projects, and it's the IN, IP, VC, the PW, and the DW. And remember, you have 2 weeks from the last Friday. So you have a total of about 10 weeks to do all the work. So given that, I would say a good pace is to at least have one mini project done by the end of every 2 weeks. However, for the beginning of the course, I would put a little more pressure in the sense that, not a little more pressure, but at the end of 2 weeks, it'd be great if you have 2 mini projects done. The IN mini project is just a very simple playing around with the grader, how the grader works. And I would say we would have covered all the material to answer all mini projects by the end of week 6. So by the end of week 6, you can answer all the mini projects. I try to keep at that pace. Maybe by the end of week 2, complete IN and IP. Maybe the end of week 4, complete VC and make progress towards PW. And that will set you up for success to wrap up all the work. Okay, let's see. What is the most lucrative domain to apply data science concept? I don't know what's the most lucrative domain, but finance is my first guess. But I don't know. I don't know. I don't know what's the most lucrative domain. I'm not really looking at salaries and how the different fields pay. But my guess is finance. All right. I see Monir sharing a bit about their background. All right. Hello, Okalady. Hamza, I mean, the way these lectures are arranged seems a little bit tedious, getting them for persons with a little poor network like myself who can get something like a mobile application. I see. Yeah, no, I think that's something to consider, and I have to, talk about that, bring that up with people. And we have an end of the year, the end of a cohort survey, so do put your opinions there. We do have the end of cohort survey, so do put those things there because I can bring it up to people, but I have to get kind of approval and figure out what's the best approach. What I will point out is that you could download the videos. So you go to video downloads and you can download the videos. So if you have intermittent internet connection, you can download the videos and then watch them on your own time. So hopefully that's a little better, but please do bring up any of those concerns at the end of the end of course survey so we can consider that and make improvements for future generations. What's the best way you will suggest for a person that's totally new to programming to learn and get good at data science fast? And I would say it's practice, practice, practice. I know that's the kind of cop-out answer, right? Practice, 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 right? You went to a little something more concrete. And I like this website called Real Python, and I can put this in the chat. I think there's a lot of great articles in there. Take a look at that. You can take a look at those articles. Maybe look for the ones that are more basic concepts. More basic Python concepts, and follow along. Practice, make errors, play with it, don't be shy, make the mistakes, learn from that. Okay, how to determine the first true in a Boolean list? Okay, that's a specific question, so I can put that in the agenda. So Boolean from a list. I'll put that on the agenda, so I'll get to it. I'm going through a couple of the administrative questions that are in the chat right now. Can you please explain the naming convention of the mini projects? How do we know which ones to do each week? And you will get out, so I will explain that. So IN stands for intro. IP is for Intro to Python mini project. VC stands for vector class. And this is about object-oriented programming. PW is data wrangling in pure Python, so Python data wrangling. DW is data wrangling with pandas. Sorry that my handwriting is a little horrible. We do send you those weekly emails. That will, in the weekly email, we do suggest what is the mini project for the given content. Tom is saying, should a data science? So hopefully that answers your question. So please look at those weekly emails because in there we tell you what is the mini project for that week, or what are the topics for the week. So please look at that weekly email we do send out sometime Monday around noon Eastern time. So you should definitely get it by the end of Monday. Should a data scientist also become familiar with R at some point, or is Python the future? I'm into Python. And so it's one of those where, yes, ideally you'd know both, but I prefer Python because it is a general purpose programming language. You can do Python for data science, or you can do Python for web development. Like this application here, this is all written in Python. You can write Python to run these finite element simulations. I don't think you could do that with R. So if you were to have, and it's all about time, and if we had infinite amount of time, you would learn R, Python, C++, Go, all the languages. But I would recommend your time is better suited to become better at Python. It's a general purpose programming language. So in other words, you learn Python for data science, but you're also learning the Python syntax, so you can jump in and do Python for other applications. And sorry, I'll get better with my handwriting. So intro to Python, vector class, object-oriented programming, Python D, data wrangling. This is a bit messy, so I'm going to rewrite that. Data wrangling with pandas. Don't know what pandas is? We'll get to it. Julia programming is better. The problem with Julia programming is it's relatively new, so there isn't such great adoption. There's not a lot of, it's not as mature. There's not a lot of packages. So who knows? Who knows what will be the common language in 10 years for data science? I would still say Python will be dominant, but languages change, right? I mean, not languages change, preferences change. So all we got to do is, if we learn Python, we learn a programming language, and that's our first language we learn, it's going to be easier for the second one. So that's my answer to Julia. All right, so I see someone question here is, if I copy IP as IP answer and run the grader, will it register my submission? Okay, so if I were, Raghuraj, your question is, if I go into maybe my server and you duplicate the notebook. So I go into, let's say, Python, and you click on maybe mini projects, and I don't know, I type in IN and I duplicate, and you can rename it whatever you want. In this case, you named it answer, and you run the grader cell, but the notebook has a different name. Does not matter. And the reason why it doesn't matter is because if we examine this cell here, this right here is the name of the question. Mini project, the name of the question, the answer you submit. So it doesn't matter what is that you're doing it in a different notebook. And to double check, you can always go Control Panel and go into grades. And here are all your grades. So it doesn't matter the name of the notebook. Could be a notebook you duplicated. What matters is that you run the grader cell and check that your score has been updated. Okay, and that, let me know if there's any follow-up questions, other things. I'm going to tackle something that someone put up, ask for the agenda, which was Boolean from a list. So the first Boolean from the list. So Raghuraj, are you interested in figuring out the position where the first Boolean value occurs? Is that what you're interested in from the list? So if the first Boolean value counting from left to right happens in index 5, you want the value 5. Is that what you're looking for? Let me know just to clarify your question. Yes, okay. All right, so let's take a look at that. And what I tend to do is I go into my server. All the weeks have been uploaded already for the week, correct? Yes, Tayo is asking a question. What we do is by Monday, all the links that we're going to upload for the week are there. So there's no additional links throughout the week. They're already there at the beginning of the week. So it's like, here you guys, go for it. Okay, so let me go to the question that was asked. One of the things that I like to do is I'm going to create a folder. You can create folders here. I'm going to rename this. I'm going to say office hours. Because sometimes I open up a notebook, a clean notebook, new, Python 3. File, rename, and I say office hours, and I put today's date, which is September 29, 2020. Ooh, September is almost over. And I like to do the work here, and then I like to upload this later on to the shared drive. So it will appear in the shared drive. In other words, it will appear, if you go to Control Panel, Downloads, it will appear in the shared drive. May not be immediately, but I do like to have those, any kind of notebooks I work on that are not related to the mini project, that I do upload that. So with that said, let's go examine that. I'm going to create a list. So my list, and one of the things I also like to do is I like to blow up my screen. It's a little hard to read sometimes, so I like to blow up my screen about maybe 150 or 125, a little easier to read. And I have, let's say, false, 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 true, true, false, false. Run that cell, and I got a syntax error. Ooh, my first mistake here. First mistake of the course. I like making mistakes. The reason I like making mistakes because it's a great teaching technique. We can debug, and I can tell you what went through my mind and how I figured it out. When we get a syntax error, that's usually a fundamental Python mistake. For example, we forgot to close the bracket, close the parenthesis, close the quote. We're missing a comma. And let's examine. Remember, when we make a list, things are separated by a comma. Ah, false, false, no comma there. Bingo. Fix that, and it ran. Yep, thank you. Yep, the comma. Thank you for pointing that out. Okay. Now we want to figure out the index where the first true value occurs. So every time we have to iterate through the list, and every time you have to iterate through a data structure, like a list, and you also want to keep tabs of the index, you should use the enumerate function. So the enumerate function is going to give us an iterable. An iterable is just a fancy way of saying anything we can iterate through Python. Anything we can say for blank and blank, if we can do that, it's an iterable. A list is an iterable because we can iterate through the elements of a list. So what I say here, I say for I, comma, x. Or I'll say x. Sometimes it's better we use something readable, but I'm not being original here, so I use x. All right, see, I see Lyndon has a question, so I'll go ahead and answer that in a bit there. For x, enumerate my list. This will iterate through the index and the value of the list. I'll just verify. I will print out I and x. Run that cell, so I should see 0 false, 1 false, 2 false, 3 false, and so forth. When I run a cell and this here has an asterisk, that means it's running. And this is taking a little longer than usual. So I'm going to do kernel, and reconnect. Maybe there was a connection issue to my pod. So I'm going to reconnect. Not the issue to my pod, maybe an issue with my browser and here. And it's still connecting to kernel, and this is a little worrisome. So I'm going to go back here, and let's see what happens if I hit refresh. It looks like my pod shut down. I don't know why. Oh well. So I'm going to close that, go back here and start my server. Don't know why it shut down. Letting that run there. Okay. Back to our regular scheduled program. Where was I? Oh, my work is lost. Oh, well. False, 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 true, false, true, true. Run that cell for I, X in my list. Print I and X. I get a name error. My second mistake. Ooh, making a lot of mistakes today. I was up since 3:30 a.m. Eastern Time. Anyways, a name error. When we get a name error, it means we are referencing something that doesn't yet exist. And that probably most of the time is a typo. So given that, think about it for a moment. What do you think? Yeah, double T, right? Typo. Name error, 95% of the time it's a typo. I forgot to use enumerate. Enumerate. Boom. Yep, thank you for pointing that out, using the enumerate. And now I get 0 false, 1 false, 2 false, 3 true, and so forth. So now, what I can do is I could figure out, I can check, right? I'm going to have a condition if X, so notice if X is true, I can do something like first true is that equal to I, and then I can break. And break breaks the for loop. Lets me exit the for loop. Okay. Take a look at a couple of questions here. So let me know if that answers your original question. In which situations is it best to use a for loop or a while loop? All right. So I'm going to put that in the agenda just so I like to look at this agenda here and keep tabs of it. So here I will say for loop versus while loop. All right, and see someone answering the chat, so thank you. It's always great to have collaboration and helping each other out. But I will expand on it. And a for loop is usually preferred in most cases. And the reason why is because you typically want to iterate through all the things or through a finite set. For example, here we have a list, so we can do a iterate through all the elements of our list. And a while loop typically is used when sorry, let me back up a for loops, and they're very definite. I say for whatever in my iterable, I will go through all of them. And I don't have to worry about it going on forever. The problem with while loops is they continue on until some condition is no longer true. So sometimes it takes a little more code, a little more lines of code to make sure that condition is being changed so that we don't get stuck in an infinite loop. While loops can be useful if you have a situation where you don't know when a condition will be met, when some condition will be no longer true. And you expect that condition to perhaps change as you go through the while loop. Those are cases where a while loop would be useful. And most of the times, you can do something a lot more succinctly and clearer using a for loop. And one of the things about Python, and as we go through this course, is Python emphasizes readability. Your code will more often be read than written. Code is more often read than written, so it makes sense that we spend time writing code that is readable. Not only readable to you, but readable for anyone else. So sometimes the preferred approach is the one that's most readable. And for loops tend to be more readable. It's easier to understand. Okay, for everything in this container, everything that's iterable, I'm doing this. So the while loop is a little trickier. Not saying the while loop is unreadable, but a little more cognitive load on you. While this condition is true, okay, what condition and how is that condition changing for every pass? A little more cognitive load. It's a little less readable in my opinion. So try to go for the for loop. But if you cannot express what you're doing so nicely in a for loop, maybe try use a while loop. What should signal there in your mind to use a while loop is that you don't know when that condition is going to come back to be false. And you have code that will be updating that condition so that it could be false. So you can break from that while loop. Okay, so I see some follow-ups here. And I see, is there an alternative to break like end? And let's see. I don't think there's an alternative to break. I think break is the way to break from a for loop. You could also return. If we had a function, you could also return. If this was encapsulated into a function, return would have sufficed. We would have used return instead. We could have written this using a while loop, right? We could have said while. And let's write it on a while loop and let's compare. And maybe we can kind of come into terms why for loop tends to be better. So I'm going to say, and the fact that I'm struggling to write in a for loop is saying that maybe this would be a bit cumbersome to use a while loop. We'll use a while loop. So I would say condition equals false. And sometimes when you write your code, you could think of it as a first draft. You might want to always change it up, make it more readable. While condition, I say condition true. How about that? Condition true. While condition, then we say something like, we can set I as a counter maybe, set it equal to 0, and saying if my list I, if that's true, then we can set condition equals false and first true equals I. And I think that would work out. And now I'm in an infinite loop because I'm not modifying I for every pass. I plus 1 equals and first true. I got the same answer. But taking a look at these two codes, the for loop and the while loop, which one do you think is easier to read and easier to understand? Think about it. Sorichi is asking, can we access these videos later? Yes, there is a playlist. While you're thinking about which one is the better approach, control panel, video links, there is this playlist right there. And I tend to do this as soon as I have a chance to do it. Let's see, copy link address, and we do post the video there after the fact. Yeah. So what are your thoughts? What are people's opinions? And I see one answer. And VD, I also sent you the link about the office hours for you to access in case you missed them. There they are. I would try to do by the end of the day. By the end of the day, my time. So, I see. Unkick saying depends on the time complexity. All right, so there's a depends on the time complexity. Anyone else want to share which one you think is the more readable solution? Also consider which solution is the easiest to maintain. Is another way to think about it. Code has to be maintained. Very rarely you write code and that's the end. That's the end of it, right? Sometimes we have to go back and modify things. So another consideration in your programs is which one is the more maintainable solution. I see a lot of people are suggesting for loop, and this is sort of an opinion, but I think most people will find the for loop easier to read. Someone says, can we access this chat too while watching the videos? And I think the answer is yes. I've looked at the videos after the fact, and the chat is still there. So you should be able to still use the videos. Yeah, and Naya, yeah, exactly. I think most people agree the for loop is easier. Someone says depends on the time complexity. Yeah, and we'll talk about time complexity later on as we go into the course. And time complexity is basically a feel for how long the algorithm would take if we were to expand how many times we use it. Yeah, and while loop it is it has some readability to it, but I think a lot of us agree that the for loop is shorter and more maintainable. And usually shorter code is more maintainable. That's not that's not a hard and fast rule. But typically if you take less lines of code to do something, it's easier to maintain because there's less moving parts. Right? It's simple machine. Think about a hammer. How often does a hammer break? Very rarely. I'm not saying a hammer is the best tool in the world, but one of the nice things about hammer is its simplicity. There's beauty in simplicity. Yeah, and sometimes if we have two approaches, we may want to consider time complexity. We're willing to perhaps sacrifice a readability and maintainability if it means that it will be faster to run. And hopefully it's significantly faster. If we're splitting hairs or it's not going to be used, not going to be scaled up as so much, then we'll make a trade-off. We may perhaps take the one that's less efficient if we think it's more maintainable. We're going to have these conversations throughout the course, right? We build that intuition, build that comfort. Okay. Can while loop crash a system if it does not end? If it does not end, then it hungs up. It could crash. It could crash your system if for every pass in the while loop it's doing something. Imagine for every pass of the while loop it's creating a file on your computer. Ooh, you might crash your system. So you might run into trouble with while loops. Someone is asking, is this unit 2? No, this is unit 1. But you're more than welcome to stay. Other things people have, I do want on Thursday. I think on Thursday we can start cracking open the first mini project. So I do plan to do that on Thursday, or maybe even on as soon as Wednesday. We'll see what Michael's agenda is. But any other, the floor is open. I think I've addressed all open questions. I've seen someone posted something, so let me look at that. Get Redder writing Pythonic code. Yeah, another thing we'll talk about as we go through the source is Pythonic. Pythonic just means the preferred way to do in Python. So we'll have those conversations. Can we connect to the server using Visual Code, as in Visual Studio Code, that the text editor, the IDE? I believe good question. I know you can use VS Studio when you're running Jupyter notebooks on your personal computer. I am not sure if there's a way to connect to a remote server. I could be wrong. I haven't looked into it. If someone does know if there is a way to have your Visual Studio program connect to a Jupyter Hub, you have to pass it your credentials, your username and password. I'm not sure. So, I'm going to put this in my agenda here. VS Connect to Jupyter Hub. If I have time, maybe I can look into it. Someone else just joining us, don't worry, the videos are posted after the fact, so if you're just joining us, no worries. Well, the video will be available later today, so you can watch on your own time. All right, any other questions people have? We're getting towards the end of office hours. Can we defer for a second time? And the answer is no. We only let you defer once. Someone is saying in VBA one can set an initial index of an array. Is it possible to do so in Python? So set an initial index for an array. And the answer is no. I don't think you can move away from zero indexing in Python. You're stuck with zero indexing, for better or for worse. I like to tell the story. Story time, guys. I like to tell the story where I was walking back home, and I live in an apartment building, and I was trying to see if I can find my unit from outside. And I thought I found my unit. I live on the 8th floor. And I was like, wait a minute, that's not my unit. I have an enclosed balcony. That one has an exposed balcony. And what I realized is I was counting the first floor as 0. I was doing 0, 1, 2, 3, 4, 5, 6, 7, 8. So 0 indexing might pervade the rest of your life. I thought that was a funny story. Maybe you guys didn't think it was funny. All right. So I hope data science can make some solid applications in digital marketing. And I believe so, especially when we go into the realm of machine learning. All right. Some people find it funny. Okay. I know it's not live, so I don't hear people laughing. So don't worry. I'm not going to be a comedian. Okay, we're a couple more minutes left. Any other additional topics you want to throw in? Working my way through the mini project. Does the IN and IP mini project don't think we have the videos to do the VC yet? That is correct. You don't have the videos to watch VC yet. And that is why I recommend by the end of week 2, a good position to be in is having completed IN and IP. All right, looks like people are finding that joke funny. Okay. Any other last things we want to bring up before we close today's office hours? I know we spent some time, introducing myself and a little bit of background, but I had fun. Hopefully you had fun too. All right, guys. Michael will take over for tomorrow on Wednesday, but after that, starting on this Thursday, I will be doing the rest of the office hours. So take care, guys. Make progress. Have a good rest of your day, and we'll see you hopefully at some point. Someone's saying, is there a WhatsApp platform people to join? I know there's an informal, unofficial WhatsApp group that's in the forum, in the question forum. People usually post that there. Can I really catch up without prior knowledge of programming? It might be difficult, but we're here to help. We're here to help. All right, guys, take care, and see you on Thursday if you join the office hours on Thursday. Take care, guys, and see you later. Have a good rest of your